Based on the edge crack study we did last year, we wanted to get to the bottom of the phenomenon on why the much better cut edge on HSC milled blanks actually offers better performance over the entire component. And we took this as an opportunity to work with a major OEM in Germany and to look at a wheelhouse where we considered certain forming operations to be critical. We have therefore selected a component together with our partner on the OEM side, with which we then went into the Forschungsgesellschaft investigation. We have included HSC-cut blanks as well as laser-cut blanks for this purpose in the investigation. We wanted to find out to what extent we could use the HSC process to avoid, if necessary, the edge pre-damage that we expose to the blank with the standard processes. And secondly, what this prevention of pre-damage at the cutting edge could mean for the entire component. No one had previously investigated this in relation to a real component. In this study, we wanted to show that the edge has an influence on the entire component and have therefore chosen the keyhole method. Why? We measured the residual sheet thickness after forming and cut small keyhole-shaped holes in the component after forming, which we can then measure later. Wheelhouses have three characteristic areas. The first area is the one influenced by the relief hole. The second is the one that is influenced by the outer edge of the sheet. And the third is the one in the inner component area. And for this reason, we have defined three sub-areas: the frame area on the inside, the area of the relief hole in the middle, and the area of the blank edge on the very outside. The central results of the study were equally surprising for us. Like everyone in the world of forming technology, we assumed that the nature of the blank edge has relatively little influence on the entire component. We have seen that there are significant differences depending on how the blank was manufactured. And not only at the edge, which we assumed on the basis of the results of Edge Crack Study 1, but also inside the component. The results have surprised us just as much, and it is our claim to understand why the results are the way they are. There is a valid theory that says that the blank edge compared to the HSC edge is so pre-damaged by conventional processes compared to HSC, where we do not have this pre-damage, that the material flow during forming either from the relief hole or from the blank holder area has an influence on the overall component behavior. The advantages are relatively obvious, because with less sheet thinning, we naturally have a somewhat safer component. If we consider performance reliability both during forming and afterwards in assembly as being constant, the lower sheet thinning means to generate a higher degree of material utilization. We want to verify this in further investigations, especially on much more critical components. We assume, however, that we will be able to, as we have now seen in the case of the wheel arc, a relatively safe and securely designed component, increase this even further in the case of components that are more critical to forming. Because we can design the component to be somewhat smaller in the method planning stage, and especially in the case of large components, thus reduce the cost of the rather expensive material aluminum, since material can be saved. Probably the most important conclusion we can draw from the study at this point is that we would like and need to conduct further studies to prove this effect again, especially for more critical components. But especially in the case of components that are critical to forming, it is also important to positively shift the possibilities for material utilization. In other words, we want to go into the method and the forming process with less material. And that is why the discussion with the method planners is extremely important here. The method planners themselves, with whom we have already spoken on the customer side, have shown great interest, especially for components such as side frames, door inner panels, which also require a lot of material, and every gram that we cut is a benefit for our customers.